So far, as we've looked at our volumes of our solids, every one of our solids have touched the axis of rotation. So that one did there. This one back here, this is the axis of rotation, we touched it. And this first one here, we touched the axis of rotation. And that's all well and good. But what happens if instead of it touching, we get a shape that's like this one?
What is that shape?
It's a solid that now has a hole in it.
Oh,
So one form might be something you guys call a donut.
We should eat a donut.
Is that for the shape name?
What we really do is we look at this, and those of you who do some things with building projects or mechanics type stuff, you call that a washer. So we take this idea of the disc method and we say if we have a hole in the middle of it, it's going to be called the washer method. So
Guess I need a new sheet of paper. Very long notes.
now, what I'm going to do is I'm just going to say this is also known as disc method with a hole. Because honestly, we will have a separate method that is entirely different from the disc method. And I don't want you to start thinking there's 3 or 4 methods that we're operating on here. Really, today we're working on one method. The thing that happens is this one's got a hole in it where the other one didn't. So what does that do for me if I wanted you to find the specific surface area only of this face of this washer? How would you do it? So you want to know this large radius, and then you want to subtract from it the small radius, well, not so much small radius, you want to know the large radius to get the area of the outside region, including the part in the middle, and then you subtract from it the area of this smaller radius shape with the hole in the middle. And that's what we're going to be doing. So the volume is again going to be pi, the integral from A to B, capital R of x, that quantity squared. Nothing different there. And again, that's the large radius.
Minus the little r.
And then we're going to have a lowercase r squared of x, and that's the inner radius or the circle, the hole that we're generating dx. So yes, the only thing you're doing different is you're going to have to think about what is the hole, what is the separation.
We'll have a line for that, won't we?
Maybe.
Maybe.
So let's look at an example of how this works. Let's determine the volume of the object formed by y equals x cubed, y equals x squared. Do I need to specify the regions here? What's the region of x's that this works under?
1 and 0.
Okay, it's in that region. That's where they cross. That's where they make a closed-in shape. If you need me to specify it, I can. But we're going to revolve this. The equation y equals 0, which is the x-axis. So again, what's the first thing we want to do? There we go.
X cubed.
So if I'm drawing this thing, let's draw y equals x cubed in red, just for red. So at 0, it's 0, correct? At 1, it's at 1, correct? And I think we did this a couple days ago. At 1/2, what is x cubed located at?
8.
So 1/2, it's way down here at 1/8. So this particular shape looks something like that. Let's contrast that with blue being our x squared graph. At 0 it is,
0.
at 1 it is,
1, 1.
at 1/2 it is,
Quarter.
it's above.
Oh, man.
Is that,
Right in the middle stuff?
so the part I'm concerned, that's a terrible graph. The part I'm concerned about here is, number one, I'm a little off today apparently. That part right in there. Now, would you agree that there's a void in the middle here if I revolve it about this x-axis? It kind of spins around, and then there's a void space, right? And that's the void space that we want to take away because it's not a solid region.
Why can't we just estimate like we did the Simpsons rules?
Well, we don't want to do the estimation. We want to know, and the answer we're actually getting to this question is, if for some reason this was like maybe a glass that I was making, I want to know how much material makes up the glass itself. Not how much it holds, but how much material is within that glass. So that way I have a better idea of how much to charge a customer for, this is my raw material amount, then I got my labor and other things associated with it. But that would be a question I want to know. So it's going to spin out and around. What is the large capital R radius of this object?
Squared minus x cubed, quantity squared.
No. The large radius is the distance from the upper curve to the axis of rotation. There's my large capital R of x radius. So what is that value?
X squared minus x fourth.
Slow down for a minute. We'll get there. Slow down for a second. And then I want to take away this lower radius right here. Lowercase r of x radius. This part I subtract off.
X cubed minus 0.
There we go. Partly because this is so important. Does everybody understand how we're making these two calculations? Where they're coming from. Once we can do this, then we need to plug it into our equation correctly.
Wait, so the little r always going to be the smaller?
Smaller, the part we take away, yes. So volume is pi times the integral from 0 to 1. And we're going to do what? The capital R of x squared. So x squared squared minus the lowercase r of x, the quantity squared. Remember, we are calculating radii values to find areas. Square them. Any questions about this? Yes, sir.
Could you do like x squared minus x cubed squared, like that whole thing?
Is x squared minus x cubed, the quantity squared, going to give me the same value as x squared squared minus x cubed squared? No, it's not. So we have to separate them out. So volume is pi times the integral from 0 to 1. This one becomes?
X4.
This one becomes?
6.
Again, that actually goes back to the question earlier. How do we apply our powers? What's our powers rules? You may have to remind yourself of some of those. Integrate this, and what do we get?
1/5 x to the 5th minus 1/7 x to the 7th.
So 1/5 this one.
And it becomes pi times 1/5 minus 1/7.
12 over 35. No, not that. Yeah.
2 pi over 35 units
Plus some.
cubed. Please don't forget the pi. Any questions about this? Yes, sir.
Are we going to end up using this to do more stuff?
Well, like anything else, when you introduce a concept that's pretty basic, yes, you can build on it.
Because I keep seeing the pie on the top, which makes me think of like trig stuff.
Yeah, probably doesn't have from trig. It's more along the lines of what it is. Could have been 2/35 pi. Other questions?